Hi students, I am going to start exercise 6.8 introduction video. The introduction topic condition for coplanarity of two lines. The first one condition in vector form is C vector minus A vector dot B vector cross D vector equal to 0. So two lines are given now, and these two lines are condition for coplanarity is a vector form of equations C vector minus A vector dot B vector cross D vector equal to 0. And the second one condition in Cartesian form is two lines are x minus x1 divided by b1 equal to y minus y1 divided by b2, z minus z1 divided by b3, and x minus x2 divided by d1 equal to y minus y2 divided by d2, z minus z1 divided by d3 are coplanar if x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3 equal to 0. Given the condition for Cartesians, two lines are now the determinant value of x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3 equal to 0. x1, y1, z1 and x2, y2, z2 is a point. b1, b2, b3 and d1, d2, d3 is a vector point. Okay. So now the next one topic, equation of plane containing two non-parallel coplanar lines. Two non-parallel coplanar lines. Okay. So now given a parametric form of vector equations. Parametric form of vector equations. R vector equal to A vector plus TB plus SD vector, or R vector equal to C vector plus TB vector plus SD vector. Okay. So two lines are now given the vector equation. So R vector equal to A vector plus TB vector plus SD vector, or R vector equal to C vector plus TB vector plus SD vector. Second one, non-parametric form of vector equation. Non-parametric form of vector equation is R vector dot A vector, R vector minus A vector dot B vector cross D vector equal to 0. Or R vector minus C vector, R vector minus A vector dot B vector cross D vector equal to 0, and R vector minus C vector dot B vector cross D vector equal to 0. And third one, Cartesian form of equations of the plane. Determinant of x minus x1, y minus y1, z minus z1, b1, b2, b3, d1, d2, d3 equal to 0. Now x1, y1, z1 is a point, and b1, b2, b3 and d1, d2, d3 is a vector. Or x minus x2, y minus y2, z minus z2, b1, b2, b3, d1, d2, d3 equal to 0. The determinant value of x2, y2, z2 is a point. b1, b2, b3, d1, d2, d3 is a vector. Therefore, the determinant of x minus x2, y minus y2, z minus z2, b1, b2, b3, d1, d2, d3 equal to 0. So, very important formula. That's all. We will meet the next class.